Thank you, Dr. Liška. Good day to everyone. So today we started with chemistry, but we will finish with biology. So this is the last lecture, but I hope not the least important today. This is research that we are doing together with the Institute for Multidisciplinary Research from Belgrade and the Institute for Biological Research Siniša Stanković. So, as I said, we started with chemistry. There was a lot of topics related to these new occurring substances in water, but it's quite difficult to discuss what will be the effects of these substances and whether this exaggerated article in newspapers will become true one day. It's pretty difficult to say. But what we can say for sure that simple detection of pollutants fails to provide the information, the relationship between contaminant exposure and biological effects in aquatic organisms, and therefore the usage of bioindicators becomes essential for assessing the condition of aquatic ecosystems. So when we are talking about ecogenotoxicological studies, different approaches are used for assessing the conditions of ecosystems. So we use in situ assessment, which is basically performed on animals collected or exposed at certain locality in environment, and ex situ assessment, where the effects of exposure are studied in controlled laboratory conditions. Further, when we are talking about in situ assessment, we use passive and active biomonitoring. So basically, when you're doing passive biomonitoring, you just go to the certain locality of interest and collect the animals from this site, and then you study certain biomarkers in these animals. And when you're doing active biomonitoring, first you have to collect the animals from an unpolluted site in environment, or you use the animals maintained in laboratory conditions, and then you expose them at polluted sites or sites of interest for a certain period of times. When you're doing passive biomonitoring, it's quite difficult to go at certain locality and collect the animals which are of same size, same age, same sex. And also because of the level of pollution and hydrological characteristic of certain sites, it's sometimes difficult to obtain any specimens from these sites. Therefore, active biomonitoring has many advantages over passive biomonitoring. Considering bioindicators in ecogenotoxicological studies, mussels and fish are commonly employed in our studies. So, for example, for the purposes of project which is funded by Ministry of Education, Science and Technological Development of Serbia, we use fish as bioindicators of quality of surface waters in Serbia. We use Qualius cephalus as shown on the previous slide. Then we had the project with colleagues from the Institute of Marine Biology from Kotor, Montenegro, and we use Mytilus galloprovincialis for assessment of water quality of Boka Kotorska Bay. And we use freshwater mussels for some studies that will be presented today in this presentation. So when we are talking about freshwater mussels and bioindicators, they are already recognized as very sensitive bioindicators. For example, wave closure and heart rate is used as early warning on the presence of pollutants in environment. They have wide distribution, they are filter feeding organisms and sessile life forms, and they have ability to accumulate pollutants, and all these characteristics make them favorable organisms for estimation of environmental pollution level.